All right, welcome to Unit 11, Right Triangle Trigonometry. Okay, before we get into trig, let's do a quick review. So look at example A. If we have a triangle, a right triangle, and we have two of the sides and we're missing one of the sides, how can we find the third side? Okay, if you can remember, we talked about a little bit about this in this year, but I think you focused more on previous math classes, is the Pythagorean Theorem. So a squared plus b squared equals c squared. And let's just draw a little triangle, A, B, C, okay. And in class I asked everyone, does it matter where you put your A, B, and C? Okay, and when we do that, we need to make sure that C is the one that matters. C always has to be the hypotenuse, or the longest side. Okay, A and B, as long as they're on one of the triangle, the legs of the triangle, it doesn't matter. We can do that way, or we could switch those A and B and we'd be fine. Okay, so to solve, we would just plug in what is given. So x squared plus 4 squared equals 9 squared. And you may set this up a little or solve a little differently. This is how I end up doing it. X squared equals, not equals 2, sorry, plus 16. So 4 squared is 16 equals 81. And then I would subtract 16 from both sides. That leaves us with x squared equals 65. And then we would just take the square root of both sides. Square and a square root cancel, and we finally have x equals the square root of 65. Alright, oftentimes the radical isn't simplified. So if you remember before, we did like these factor trees. So if we factored out something from this number, we could do like 5 and 13. Okay, and that is completely, the factor tree is completed, but we don't have a group of 2. So we're just done, and our answer would be x equals the square root of 65. All right, let's have another look. So we could call this A, we could call this B, and our hypotenuse is always C. So here we could set it up, 5 square roots of 2 squared plus 9 squared equals x squared. All right, so we'd want to simplify or evaluate this first term, and we can do that by just distributing that exponent. So we could do 5 squared, that's 25, and then what is the square root of 2 squared? Okay, so remember, a square and a square root cancel, and that just leaves us with 2. Plus 81, okay, and then that's equal to x squared. We can combine like terms, so we could simplify that if we wanted to, or we could just plug it in our calculator, and that would give us 131 equals x squared. Square root both sides, and we just end up getting x equals the square root of 131. All right, and we can't simplify that. That's a prime number. Let's look at D. So here we could do A, B, and C. 10 squared plus 10 squared equals x squared. That gives us 100 plus 100 equals x squared, or 200 equals x squared. And then we could square root both sides. The square and the square root cancel, and we end up getting x equals the square root of 200. In this case, we can simplify. All right, so we'd want to do our factor tree. All right, we could do 2 and 100. And then we could also realize that 100 could be 10 and 10. And that's 2 groups of 2. So that could come out, and we could say x equals 10 square roots of 2. Okay, so this the square root of 200, basically when we do this factor tree, we are rewriting this as 2 times 10 times 10. Okay, and this could also be written as the square root of 2 times the square root of 100, which is 10. Okay, so whichever way you want to do this, factor tree is what we usually do. All right, and then C is just another example. I'll leave that to you. Okay, so what is trigonometry? So in class I asked, what does this look like? What does this sound like? Okay, and that kind of sounds like triangle. Okay, and that's kind of what we're talking about, is triangles. Metry, or like geometry, or what are some other words that go with metry? Let me see really quick. Kind of sounds like meter. All right, metry. It says on dictionary.com, it says metry, word forming element meaning process of measuring. Okay, so like geometry, we measure shapes. In trigonometry, what do we measure? We measure the triangle. Okay, and what can we measure on a triangle? We could measure sides, there's 3 of them, and we can also measure angles. So that is basically what we are going to be covering in this section, in this unit, is trying to find angles or sides of a triangle. And that's pretty much it. So, in able to do this, we should learn a little lingo, okay? So, okay, I missed this. What is a trigonometric ratio? Okay, so when we do a ratio, we'll always be talking about, a ratio is like a function. A function, no, sorry, not a function, a fraction. A fraction, or a ratio of 2 sides of a triangle. Okay, so here, this is how we will call sides of a triangle. Okay, first off, we'll have a reference angle. So for example, here we have an angle, and that will be our reference angle. This is how we're going to call out the other sides of the triangle. So one of them is the opposite side. Opposite side of that angle, we would write here, would say opposite. Okay, adjacent side is the side next to the reference angle. So right here would be the adjacent side. And then hypotenuse is always the longest side, and it's also across the right angle. Okay? All right, so here are an example of 4 triangles with a reference angle. I would like you to pause, please, and see if you can write down opposite, adjacent, and hypotenuse for each triangle. Oftentimes, we will abbreviate this information, the opposite, adjacent, and hypotenuse, by OPP, ADJ, and HYP. Okay. We could also just do O, A, and H. Just make sure that if we're using a triangle angle, that if it's A, you don't want to get confused if you have 2 different types of A. Okay. Anyways, so pause, do those 4 problems. All right. So here's our reference angle. The adjacent side is right next to it, and so we'd write A, opposite, and hypotenuse. Okay, or you can always start with your hypotenuse. Sometimes it's easiest to find those hypotenuses or whatever. Okay, and then we'd write our adjacent which is also next to that angle, and then opposite is across from that reference angle. All right? So you're saying, Mr. Warner, that's okay, I can write those things down, but what do we need them for? Okay? So there is a relationship between an angle and a ratio, a trigonometric ratio. Okay, so if we have two of these, like a ratio of, say, opposite over hypotenuse, that would be a ratio, then there's a relationship between that and the angle. Okay, and that relationship is a function called sine. Okay, S-I-N-E, sine. We don't call it sin. Okay, sine. So there's a relationship between angle, here we call, this is called theta. Theta, actually I think it's T. T-H-E-T-A. So there's a relationship between that angle and that relationship, which is opposite over hypotenuse. Okay, there's also another relationship between the angle and the adjacent and hypotenuse is cosine. And then the other pair that we haven't circled yet, which is right here, is our tangent, which is opposite over adjacent. Okay? Opposite over hypotenuse. Adjacent and hypotenuse. Opposite over adjacent. Okay? And the best way, so just remember, this is just a relationship. Sine, this is a function. So it's something you plug in and one thing comes out. So if we plug in an angle, it would pop out this ratio. Okay? So how we can remember this is we can take the first letters of each term. Okay? And it will spell something. So we have so, S-O-H, ka, toa. Okay, and I think some of you have heard about that before, but that's what we're talking about. Is the relationship between sine and its ratio, cosine and its ratio, and tangent and its ratio. All right, so we'll be wanting to memorize this. Say SOHCAHTOA as often as you can, okay? Or write it down as many times as you can until you memorize it. SOHCAHTOA. Okay? All right, so let's work on some problems based on what we've talked about. First, ratios. Okay, it says find the ratio of the trig function indicated. Okay, a ratio, again, is never a decimal. It's always going to be a fraction. Okay? Something like A over B or something like that, some sort of ratio. Okay? So here they want us to find that ratio for tangent theta. Okay? So we'd maybe want to write down SOHCAHTOA. We're going to be using tangent. And what is the ratio? Well, it's opposite over adjacent. Well, we need to find out opposite over adjacent. We need to find what opposite is, the opposite side of that angle and the adjacent side. Okay? So here would be adjacent, here would be opposite, and here would be hypotenuse. It's the longest side. Okay? So all we need to do here is plug in our opposite, which is 12, divide it by 16. Simplify, okay, and that would simplify to 3/4. Okay, so let's give it another shot. B, cosine z. All right, so last time it was theta, and they showed a little theta here, but for B they said angle z. So angle z will be unite right where that vertex is for v, or z, sorry. Okay, so we'd maybe want to write down our opposite, adjacent, and hypotenuse. So here's hypotenuse, it's the largest. Okay, here we have opposite and adjacent. Okay, but we'd want to say, well, what is our ratio for cosine? Well, here's cosine is equal to adjacent over hypotenuse, or 28, sorry, 28, sometimes I can't read this very well, 28 divided by 35. And then you'd want to say, does that simplify? And it sure does. Okay. That would give us 4 out of 5. Oops, I did that backwards. I'm sorry. It's like, that doesn't look right. Okay. Adjacent's right here, 21. So 21 divided by 35. Blast. Okay, there, that's where it is. 21. So that would be 3 out of 5. Sorry about that. Okay. Cosine x, so basically the same thing. So A is A over H. Okay, our angle is going to be x. So we have adjacent, opposite, hypotenuse. So adjacent is 10 divided by, that looks like 26. Okay, simplify, we could do 5 out of 13. Right? So hopefully you've been pausing, try some of the problems. I'm going to go and do the next 3. So try and pause and see what you can do. Okay, sine, so katoa, so O over H. Here's our angle. We have adjacent, opposite, hypotenuse. So opposite is 15, and hypotenuse is 25. So that would be 3/5. Okay. Sine of A, or yes, sine of A. Okay, so again, so katoa, so O over H. We need to write down our adjacent, opposite, and hypotenuse. So this is a little trick because, I mean, these sides, I mean, just looking at them, they look about the same. Okay, I mean, they're one's 40, one's 41. So we need to make sure hypotenuse is the highest one. And just another reminder that the hypotenuse is always opposite of that right angle. Okay, so let's see what we can plug in. So opposite looks like 9, and we divide by hypotenuse, which is 41. And that would be as far simplified as it can be. Okay, and then the last one. This one is a little tricky, and we will go over it. So here we got tangent, so katoa, oa. Okay, here's our angle. This is our adjacent, opposite, and hypotenuse. Okay, opposite is 5. Adjacent is 4 square roots of 6. All right, so here's the deal. We're not done with that problem. Let's look at this. It says rationalizing the denominator. So here for that problem we just barely did, we have a square root of 6 in the denominator. Okay, so that's irrational. And we don't want irrational numbers in the denominator, whether it be convention or some people say that it's easier to understand just looking at the answer, what it means. Like, for example, 1.4 divided by 2 makes a lot more sense than, or I don't know, I guess maybe I shouldn't say it that way. Like the square root of 2 over 2, does that make more sense than 1 over square root of 2? Either way, you probably, I don't know if, sometimes people say that this makes easy, or it's more understandable to have it written that way rather than this way. Okay, so let's just talk about it. Anytime we find a radical or a root into the denominator or the bottom of a fraction, we need to remove it by rationalizing the denominator. Okay, and I'll show you how. This isn't going to be like a big focus on your homework or quizzes or tests, so it's good to know, and if you don't know how to do it, it's not going to kill your grade on the test, but it will be there. All right, so this is how you do it. We have a square root of 3 in the denominator. We want to get rid of it, okay? So what could we multiply this by to get rid of it? All right, and what we will do is we will multiply it for both sides, the square root of 3. Square root of 3 divided by square root of 3 is just 1, so we haven't changed anything, but it will help remove the irrational number on the denominator. Okay, so we can rewrite this as, whenever we multiply two square roots, we can rewrite it as 5 times 3 divided by the square root of 3 times 3. Right? Okay, so let's break this into apart. So let's do square root of 3 times the square root of 3. We already wrote that that's the same thing as the square root of 3 times 3. That's the square root of 9. And what's the square root of 9? Well, it's just 3. Okay? The top part, square root of 5 times the square root of 3, that would be the square root of 5 times 3, which is the square root of 15. And this is already simplified. So here what we would have is the square root of 15 divided by 3. And that would be our final answer. So if you notice, and you'll be doing this all the time whenever you rationalize the denominator, is you multiply just the irrational part, just the root, and the number inside, and multiply it by this fraction. Okay? So if you go from this part, you could go straight to here and just say, okay, well, let's look at this one. We're going to multiply it by the square root of 2 divided by the square root of 2. We know that when we multiply the square root of 2 times the square root of 2, that will just give us 2. And in the top, we'll just have the square root of 2. Okay? Let's try another one. So this one, if you wanted to, you could simplify the square root of 8 first. Because we know that the square root of 8, if we did a factor tree, that would be 2 and 4, and 2 and 2. So this is the same thing as 2 square roots of 2. So we could rewrite this as 12 divided by 2 square roots of 2. That could simplify by 6 over a square root of 2. Okay, and that could help us go a little faster on to solve this problem. But we'd still do the same thing. We'd square root of 2 divided by square root of 2. Okay, so that would give us, we know that the square root of 2 times the square root of 2 is just 2. And we're going to have 6 square roots of 2. Can we simplify that further? You bet you can. That would give us 3 square roots of 2. All right? So you may need to go back and watch that or think about it a little more. But like I said, it's not going to be the main focus. It's just going to be a small part of what we are covering. Okay? All right, so, I mean, like on the test, there wouldn't be just something like this. Most likely it would be a problem like 5, and I'll go ahead and do one of those. So for example, C. They want us to find the ratio of the cosine A. Okay, so A is this angle. We'd want to write down our adjacent, opposite, and hypotenuse. And we know for SOHCAHTOA, our ratio would be A over H from here, okay? We know what A is, we know what H is, so that would be our ratio. So A is 6, divided by 2 square roots of 10. Okay, and again, now we have an irrational number in the denominator. We have a root in the denominator. So we need to remove it. Okay, so we could simplify this first if we wanted to. 3 over the square root of 10. But then we would multiply it by the square root of 10 divided by the square root of 10. We know that the square root of 10 times the square root of 10 is just 10. And then we'd have 3 square roots of 10. And that would be your answer. So it'd be more something like that. And if you had the problem and you got to like this part and you didn't know how to remove that or rationalize the denominator, I mean, you'd still be having, you know, that much credit for just getting to that part, right? All right, if you need more help with that, come and talk to me. So this is the main important part, okay? It says, what happens when you need to find a missing side? But if they only give you the side and an angle, this is where we can use trig to help us. Because trig ratios are set values that apply to any right triangle. We can use trig ratios to solve a missing side. Okay? And today we're going to be focusing on sine. All right, next time we'll be focusing on cosine and tangent. But they're basically the same. So anyways, I don't want to get into that. But in order to use sine, we use the opposite side, and we already know this from the reference angle and the hypotenuse. Okay, because we know that so is our opposite over hypotenuse. Okay? All right, so solve x, round to the nearest hundredths. So please do that. It'll say this on most of your homework and your quiz and your test to round to the hundredths. So make sure you have that right so you get full points. Okay. All right, so for example, assuming that we didn't know that we were supposed to be using sine, let's just start what we know, okay? So here's the angle that they give you. Let's write down our opposite, adjacent, and hypotenuse, okay? So hypotenuse is the largest, adjacent, and opposite, okay? They give us information for the hypotenuse and the opposite, okay? The only, for SOHCAHTOA, only sine uses opposite and hypotenuse, okay? So it's the only trig function we can use, okay? If they gave us adjacent and hypotenuse, then we'd use cosine. Or if they gave us the opposite and adjacent, we'd use tangent, okay? But since we're only going to be using the hypotenuse and the opposite. And the opposite because that's what they're looking for, okay? So we would plug this all in. We're going to be use sine of the angle, which the angle is 49, is equal to the ratio of O opposite divided by hypotenuse. So opposite is x divided by hypotenuse, which is 14. Okay? And then we just want to solve for x. So how do we get x by itself? Okay, we will multiply 14 on both sides. That would cancel. And all we have is x equals 14 sine of 49. Okay? And all we would do is plug that into our calculator. Okay. You know, I don't have my calculator anymore, my graphing calculator to show for those who are using a graphing calculator. But when you plug this in, oftentimes your answer will be negative, okay? And that means that something needs to be changed, okay? Remember 2 units ago we talked about degrees and radians? Okay, oftentimes TI calculators or graphing calculators will automatically use radians, okay? And you need to switch it to degrees. So the way you do that with a TI is at the very top of your calculator, you'll see second, okay? But next to that, to the right of that, it says mode. So you're going to want to click on mode, and if you go scroll down 2 times, it will have radians and degrees. So once you get down to that point, just click right 1 time, and it should be on degrees, and you'll push enter, and it will switch it from radians to degrees. Okay? All right? And then you'll just get out. You can do second, exit, or whatever. And then you'll plug in just what it says here. So you'll do enter, you'll put in 1, 4, then you'll click on sine, and it will put SIN with a bracket, and you'll put in 49. Okay, you can close the bracket or you can leave it open. It won't make a difference because we're not writing anything after that. Okay, and then it will give you x will be equal to 10.57 because we round to the hundredths place. Okay, and that would be your answer. If you didn't get that answer, come and talk to me and bring your calculator, and we can figure that out. Okay. All right. So give a try with some of the other ones. All right, and come back to me. All right. So here again we have our angle. This would be our adjacent, opposite, and hypotenuse. We're going to be using hypotenuse and opposite, which that's so for SOHCAHTOA. So we'd do sine of 21 is equal to opposite over hypotenuse. So same thing, the only thing really different is the angle. So multiply 14 on both sides, and then we'd plug this into our calculator. Okay, this time I think we get x equals 5.02. Okay, let me double check. So 14 sine of 21. Yep, so we'd round to 5.02. Okay, C is a little different, so let's go over this one. We have our angle. We'd write down our adjacent, opposite, and hypotenuse. So again, we're using hypotenuse and opposite, which is so. Okay, so we'd do sine of, I think that's 59, equals opposite, which is 19, divided by x, which is our hypotenuse. Okay, and we need to solve for x. So before, with these other problems, all we needed to do was cancel out the denominator and bring it to the other side. Okay, here would basically, it's a little different, but we'd basically do the same thing. We can multiply x on both sides. That would give us x sine of 59 equals 19. And how do we get x by itself now? Okay, how we do that? Oops. Is we would divide both sides by sine of 59. This would cancel, and we'd get x equals 19 divided by sine of 59. And that's would plug this part in. Okay, so if you notice, we started at x equals, no, we didn't start at x equals, we started as sine 59 equals 19 divided by x. So what do you notice the difference from going from here to here? Okay, so you may notice that all we did, really all we really did is we just switched these two. And you're welcome to do that, or you can follow all the work, okay? But here I give you permission to not show the work, to go from this point to this point, okay? But I would like you to write both of these, okay? So if you do your homework, do both and just switch them out, and then you'd plug this part into our calculator. So we do 19 divided by sine 5/9. Okay, and that gives us 22.166, and we round to the hundredths, so 1/7. Okay. I think this one's basically the same one, so maybe we'll skip D. If you need extra help, let me know. Okay. So I'm just going to skip this reading part, okay, and we're just going to talk about it. Okay, it says find the indicated angle. All right, so we're going to do the same thing. Here's our angle. We're going to want to write down our adjacent, opposite, and hypotenuse. Adjacent, opposite, and hypotenuse. Okay, again, we are using hypotenuse and opposite, so we'd use so for SOHCAHTOA. We'd do sine of theta, or x, or whatever you'd like to call. I don't like to use it as a question mark. Okay, maybe I'll write it as an x. Sine of x is equal to opposite over hypotenuse. Okay, and we want to solve for x. All right, so look at your calculator and look where you clicked sine, and look right above it as if you were to do second sine or shift sine or whatever yours look like. It shows you something called something like this, okay? And the word for this is a sine inverse, okay? Inverse, not inverses, inverse, okay? So it basically does the exact opposite of what the function sine does, okay? Kind of like when we do the square root and we square it, those are like inverses. Or 2 is the inverse of the square root of 2, or the square root, okay? So sine inverse is the inverse of sine. Okay, so to get rid of sine, we could do sine inverse. That would leave x by itself, but we need to do it to both sides. So it'd get x equals the sine inverse of 7/25. Okay, so we just plug that in your calculator. So we'd do, so for like TI, you'll do second sine. For my calculator right now, it says shift sine. Okay, and it'll show this part, SIN to the -1 parenthesis, and then you'll just type in 7 divided by 25. So you don't need to, that's all you need to do, okay? And that would give you 16.26. Okay, round to the hundredths, degrees, and you got it. Okay, so let's give it another shot. All right, so here's our angle. This would be adjacent, opposite, hypotenuse. Okay, and let me just rewrite these. These are kind of hard to see. So this is 64, this is 80, and this is 48. Okay, all right, so here they give us every side. Okay, so for example, for SOHCAHTOA, if we wanted to, we could use sine, which is opposite over hypotenuse. We could also use adjacent over hypotenuse, which would be cosine, or we could also do tangent, which is opposite over adjacent. Okay, in this case, you can choose whichever one you want. You only need to do one. I'm going to go all, I don't know, I guess it doesn't really show you a whole lot, but you could, in class I did all three of them. So for example, if we did sine, oh, that is not it, sorry. Sine of the angle, which is 48, okay, we'd need to do opposite over hypotenuse, which is, oh sorry, it's not 48. That's what we're trying to find. Okay, 64 divided by 80, that's our opposite over hypotenuse. Okay, so we'd get x, if we did the inverse, we'd get x equals the sine inverse of 64 divided by 80. Okay, so we'd do, I'd put it on mine, I'd do sine inverse 64 divided by 80, and that would give us 53.13 degrees. Okay, and then I would challenge you to do it for cosine and tangent. Okay, would have x equals the well, let's do cosine first. Cosine inverse, okay, but for cosine it's ca, which is adjacent over hypotenuse, so that would be 48 divided by 80, and that would also give us 53.13 degrees. Same thing for tangent inverse. We would do opposite over adjacent, which is also 53.13. Okay, so you only need to do one. Oftentimes they don't give you a choice. They'll only give you two of the sides, and you'd have to say, well, are we going to be using so, we're going to use ka, or are we going to use toa? Okay? C and D are basically the same. So I'm going to leave that for you. And if you have any questions, please let me know. And I'm probably will also post the next one very soon. Okay, see ya.